Thanks for joining me today. Today we are going to continue our discussion of moles, but we're going to talk specifically about compounds and how they're put together. So let's talk about percent composition, how things are put together, their composition. So before we start talking about that, we need to talk about this thing called the law of definite proportions. The law of definite proportions states that regardless of how much of something you have, a given compound is always composed of the same elements in the same proportions. So water is 2 hydrogens and 1 oxygen. Always. If it's anything other than 2 hydrogens and 1 oxygen, then it's not water. So that's what the law of definite proportion tells you, is each compound has a defined proportion for the elements that are in it. And so that's what percent composition is all about. We can always figure out what a compound is if we know what it is made up of and in what proportion it's made up of. That's how we can identify unknown compounds. So if I find a sample of a compound and we do an analysis of what elements are in it and in what proportions, then we can figure out what element or what compound we're dealing with. So that's what percent composition is. It's a percent by mass, and so we look at the masses of the elements and the overall mass of the compound. So the steps to finding percent composition are pretty simple. First, you find the total mass of each element in the compound. So you take the individual element's mass and then you multiply by how many times that element occurs in the compound. Then you find the total mass of the compound by adding those all together. And then you're going to divide each mass by the total mass of the compound and multiply by 100 because it's a percentage. And a percentage is exactly what it sounds like, part of 100. So you're going to take the part and divide by the whole, and you get a fraction, and then you multiply that by 100 to get your percentage. So if you do it correctly, your total percent should be 100%. Now, it's not always going to be exactly 100% because our measurements are not perfect, and we end up rounding off numbers. So when you round, you may end up with a total percentage of 99.99 or 101.01, and that's okay, but they need to be really close to 100. If you do all your calculations and your total percentages add up to more than 100 or significantly less than 100, you probably did something wrong, because if it's a percentage, it should add up to 100. You cannot have more than 100%, and if you're doing all of it, you can't have less than 100%. So that's the way you can check your answers afterwards, is add up all of your answers. And if you get exactly 100% or pretty close to it based off of rounding, then you know that you probably did it correctly. So let's do some examples. We're going to find the percent composition of each element in ammonium dichromate. So ammonium dichromate has the formula of NH4 Cr2O7. So if I want to find the percent composition of every element in this compound, what I'm going to need to do is write down first all of the elements. I have nitrogen, hydrogen, chromium, and oxygen. These are all of the elements that are involved in this reaction. And so I figure out the total mass of each element. So nitrogen has a molar mass of 14.007, and there are 2 nitrogens. I have N times 1 nitrogen here times 2. So there are 2 nitrogens. That's a total mass of 28.014. Hydrogen's molar mass is 1.008, and there are 4 times 2, that's 8 hydrogens in that compound. So that's a total mass of 8.064. And then chromium has a molar mass of 51.996. And I have 2 chromiums, so I multiply that by 2, and I get 103.992. And then oxygen's mass is 15.999, and I have 7 oxygens, and so that's a total mass of 111.993. So I found my total mass of each element, and now I'm going to add those all together. So I simply add these all together to get the total mass of the compound. So far, this is exactly like finding the molar mass of a compound. That's actually what we're doing. So we have a total molar mass of 252.063 grams per mole. Now, that is the mass of my whole. So now to find my to find my percent composition, I'm going to take my part and divide by the whole. So I'm going to take my 28.014 and divide that by the 252.063. And then I multiply by 100. And I do that for all of them. So I have my 8.064 divided by 252.063 times 100, and 103.992 divided by 252.063 times 100, and 111.993 divided by 252.063 times 100. So I do that for all of these, and that gives me my percentage. So I do the first one, and that gives me 11.11%. Now for this, since these are technically all constants, but we don't want to have numbers just running off, for this we're always going to round our numbers to 4 significant figures, always 4 significant figures. So when I do my 8 divided by the 252, that gives me an answer of 3.180%, rounded to 4 significant figures. And when I do that division, I get 41.26%. And when I do this one, I get 44.43%. So these are my percentages. So this is 11.11% nitrogen, and this is 3.180% hydrogen, and 41.2% chromium, and 44.43% oxygen. This is the percent composition of ammonium nitrate, or dichromate, sorry. And so if you wanted to add all these together to make sure, they should add up to pretty much 100, and they do. They add up to 99.98, which of course is not 100, but like we just said, we rounded these off to 4 significant figures. If I had carried these out to everything that my calculator gave me, then they would add up to exactly 100. But I didn't do that. I rounded off to 4 significant figures, and so I get my answer to 4 significant figures, which is really close to 100. So now let's do this example. We're going to find the percent composition of each element in iron thiocyanate. Again, it's the same thing. So first we're going to start off by giving us the formula. Iron 2 thiocyanate is FeCnS2. So there's my formula. So I know that I'm going to have iron, carbon, nitrogen, and sulfur. Those are my elements. So again, iron's mass is 55.845, and there is 1 iron in this compound, so that's 55.845. Carbon's mass is 12.011, and there are 2 carbons in this compound, so that gives me a total mass of 24.022. Nitrogen's molar mass is 14.007, and there are 2 nitrogens, and so I have a total mass there of 28.014. And sulfur's mass is 32.066, and there are 2 sulfurs, so that is a total mass of 64.132. So these are my total masses of each of my elements, and so now I'm going to add these together to get the total mass of my compound, and that's 172.013. So this is my total, and these are my parts. So now to find my percent composition, again, I do my part, 55.845, divided by the whole, 172.013, and 24.022 divided by 172.013. and then 28.014 divided by 172.013, and 64.132 divided by 172.013. So again, this is kind of tedious, but it's not that complicated. Now I'm going to divide those, and each one of those also needs to be multiplied by 100 because it's a percentage. So we have to multiply by 100. All right. And now when I do that, that gives me an answer of 32.47% iron and 13.97% carbon, 16.29% nitrogen, and 37.28% sulfur. So this is my total percent composition of each element. Now, if I add these together, my total percentage there is 100.01. So that is, of course, really close to 100. And so we have an answer that is pretty much what we need. So now that we have gone through a couple of examples, you can see that the percent composition is not very complicated. It is time consuming, but it's not really that hard to do. So you simply add up all of or find the total mass of each element, and then you divide by the total mass of the compound and multiply by 100 to get your percentage. You're not always going to be asked to find the percent composition of every single element. Sometimes you're only asked to find the percent composition of one element. So if that's the case, you simply find the mass of that one element and divide by the total mass of the compound. And it's a lot shorter and not nearly as long as finding the mass of every element or the percent composition of every element in the compound. So this is not super complicated, but it is very, very important for what chemists do and how we figure out what a chemical is. This is actually used to determine what chemicals are when we don't know what they are. So it's a really important thing that chemists use, very important skill. So hope you enjoyed this. Thanks for watching and have a day.